Therefore, make sure that you understand this is only positive value to be used. You evaluate it. If it's positive, you take a consideration. If it's negative, you say 0. Okay?
Sir?
Yes.
So if they're both positive and U is 1.
If it's both positive, you consider both of them. If it's this positive,
Okay. So if they're both negative, I'm sorry, and U is 1.
And if it's both negative, you assume 0, 0 become 1.
Okay, perfect.
Okay. Again, for horizontal enclosure for air contained, this relation can be only used for this range of Prandtl number. Okay. Therefore, this is the equation that we use for this one. This equation that I mentioned is for water and silicon organism. Okay. Therefore, be careful. There are a lot of equations. Therefore, you have to understand which equation apply for which scenario. Okay. Again, as we mentioned, if the top plate is hot, the Nusselt number is equal 1. Okay. Remember, this is only pure conduction because the cold air sitting here. There's no energy to move them up. The hot air has been sitting here. Okay. Now, this correlation has been developed mainly for solar collector because there was a lot of research going on in 1980 and 1990. Therefore, this is the case that we have two classes of solar collector, and therefore they are inclined. Therefore, they have to angle it because this way you get maximum solar radiation during the day. Therefore, this is the case that you have cold plate, hot plate, and this glass outside hot can act as a cold plate. Okay. Therefore, here on the top of the absorber, the temperature is very high, and here is cold. Therefore, mentioned this is the correlation that you can see is a version of the equation that we had that before, one format of this one, but also indicated the theta, the angle, because it's inclined in theta, and also mentioned the restriction that Rayleigh number has to be less than this one, theta has to be between 0 and 70, and this, the height and the spacing, this is L, and this height has to satisfy this condition, has to be more than 12. Again, remember, please, when you calculate the Rayleigh number, the characteristic length is the spacing, L. That's why I mentioned L here, L here, L here. That's remember. But also give you some other correlation that you can use to calculate that one. Again, here it's mentioning the value, theta. Here that you have the critical run mentioned that the value we have in this equation, because there's one equation that I don't have it here. It mentioned what is the critical theta that you can use it. Okay. And for this can be applied for any of them. This apply for any length. There's no restriction. And if it's less than 0, it's between 0 and critical. We have another equation to give you critical. You use this equation. If it's between 90 and 180, you use this equation. Again, this is referring to the critical angle that we have. And when it's vertical, again, vertical, you have some other correlation. This is exactly applied for the window. The height is h. The distance between the plate is L. Temperature T1, temperature T2. Okay, it could be this one to the mother. Either the circulation happen like this, or it comes like this. Mention the Nusselt number. You can calculate here any Prandtl number. Therefore, you have no restriction. Could be for any type of gas, fluid, and so on. And mentioned, but the only condition that have to satisfy if H over L is between 1 and 2. As you can see, H is this one, and L is this one. Therefore, that can apply very small window. You can use this equation. If it's this one between H over L is between 2 and 10, you have to use this equation. Therefore, you please pay attention that all of this correlation again came up experimentally. Therefore, make sure that satisfy that requirement. You have some other option. You have this option and this option, but this option is for Prandtl 1 to 2. Okay, this is the same here. Okay, there is restriction in this range. Here you have no restriction. Here you have restriction between 1 and 20. Okay, therefore make sure that it is less than 1, we cannot apply this correlation. If you remember, the Prandtl number of air is 0.7. Therefore, when it's air, you cannot apply this one. For water, you can apply it. For air, is Prandtl number is around 0.771 and so on. Therefore, you cannot use this equation for air. Okay.
In the exam, we need to write all these equations with us. In the
you're asking that so many difficult questions there. If it's given in the table, you can. I will provide you. But if it's written like this, you're responsible. You can bring 2 pages of equation.
It's not page. 2 pages will not be enough for all those equations.
4 become 4 pages there. This side, back side, this side, back side. If you want, I can give you 10 pages, but you are wasting your time. So anyway, write it down and tell me how many pages you would like to bring.
Thanks.
No problem. Again, therefore, make sure that it's satisfy the requirement. Okay, therefore, these 2 equations definitely you cannot apply for air or any gas because the Prandtl number is more than 1. Okay, and again, make sure when you're calculating the Rayleigh number, characteristic length is L. Make sure that all the physical property calculated average temperature of the 2 plates. Okay, for something these are you have to keep in mind that way. Now, after all of this discussion, please do this problem. Please do it. Again, my friend, this is your decision. You want to do it or not. Please do it to see where you're making mistake, that you do not make that mistake during the exam. That's all I'm trying to say. Because some of the mistake you made is really, really indicate that you have not done anything practice. Therefore, you have here the distance between the L is 0.1, the H is 3. In one case, the temperature is -10, the other side is 30. He would like to give you some idea about the issue of convection. Okay, therefore, he's asking you read the question. Read the question. Determine the ratio of heat transfer from horizontal to that vertical. He wants to find the ratio, okay? Therefore, don't try to calculate the convective heat transfer and so on, okay? Read the question and try to answer to the question. Any suggestion? Okay, let's go back. We have this set of equation for vertical plate, and we have also some good correlation for horizontal plate, okay? He's asking you to find the ratio, okay? Therefore, we have this temperature difference. We have the characteristic length. We have correct distance, and so on. We can go back and calculate the Rayleigh number. Okay. Therefore, again, we assume it's a steady state condition. The temperature on the surface does not change. We assume the air is ideal gas law and thermal property constant. Since the temperature is the same as -10 and 30 for both scenarios, therefore we can calculate the physical property again using the table that we have A15. Conductivity, viscosity, kinematic, Prandtl number. Look at here, the Prandtl number of air is 0.73. Okay. And also beta can be defined as 1 over the film temperature, and film temperature is the average of the surface temperature that we have. Okay. So I'll do it. Then the characteristic length, as mentioned, is mentioned. In this case, when we're talking to the enclosure, the characteristic length is the spacing between two plates. Okay. Therefore, now we have physical property. We have characteristic length. We can calculate the Grashof number. Please calculate the Grashof number. Is G beta. G beta, we have G 9.8. Temperature difference, characteristic length is 0.1 to power 3, and kinematic viscosity to power 2. Okay. Therefore, that's the equation that you have. G is like this one, beta is this one that we have. Temperature difference 30 minus -10 become plus 10. 30 minus -10 become plus 10. This one here. Therefore, you have found this is your Rayleigh number. We go back and trying to see exactly what is the scenario where we have to deal. Okay. Now, the first thing we have to check to see if those correlations that we have over there to satisfy, because you're asking us a number of conditions that we have to make sure if it's horizontal plate or vertical plate, and which equation can satisfy your requirement. Therefore, if you have your textbook, open your textbook trying to check which one satisfies. Okay. Therefore, now we have the aspect ratio called H over L. This is the term they're using, aspect ratio. Okay. It's over there is 30 because it's 3 meters divided by 0.1. Therefore, we have to use this correlation. As I mentioned, we have the Rayleigh number from the previous page. You place it here and make sure if the term is positive, you consider it. If it's negative, you don't ignore it. Check to see which one you have to ignore it. Okay. Check which one is. If you calculate for horizontal scenario, it's become 10.94. This is for horizontal case that we have. Let me go back again one more time. I'm sorry. We have to go back, and now we have for vertical case. Okay, to see which one here. Definitely, we cannot use this one because these are for Prandtl number more than 1, and we have to verify if it's this scenario or this scenario. Which one has to be? Okay. Again, here is this expression that we have to see which one satisfies the requirement that we have. Okay. Therefore, we go back. Therefore, we calculate this one for horizontal, and we check. We can see this one, the correlation that we have to use. Rayleigh number, Prandtl number, L over case here. This one.
Sir?
Yes, sir.
The aspect ratio is a lot more than 10. So we consider either or. So if the ratio is good, we can use it. But if it's not, but the other one is okay, we can.
That's very good point, sir. Very good point, sir. This one you're talking about here, right?
Yeah.
Again.
So the second one, the RA is good.
Let me just go back. Let's look at here what we do. So we use it here.
It's 5.003.
And let me go look at here. You use this equation. Okay.
Yeah.
This equation. Okay. Can I use it or not? The question here is, let me go here. Did I cheat or am I correct here? These are something that we have to make sure.
You probably cheat.
I'm using this one, right?
Okay.
Therefore, I have
Yes.
either option of this one that
Mhm.
doesn't satisfy because it's not less than 2,
Exactly.
and this one parental does not satisfy. Considering that your textbook have give you 2 equation only, either this or this, you can assume we
Okay.
can use this one, or you can mention my parental number is 0.73, therefore it's almost I can use this one. Okay, therefore we use this one. That's why I stress about the parental number, because here with only your textbook you have these 2 equations. Okay, therefore we mention
Okay.
this. I use this equation, but with understanding does not satisfy this requirement. But there
All right.
are, if you are involved in the design, there are some other equation that you can use. Okay, very good.
Okay.
Therefore, yes, we use this correlation here, but one assumption that we make that we can assume that can be applied for R also too. But in reality, mentioned parental number has to be more than 1. In our case, parental number is 0.73, is less than, but we assume that can be still applied. Okay, there are all the equations, there are some error. By using this one, we make more error. Okay. He asked me to find the ratio of horizontal to vertical. For horizontal, this is the equation that we have. This is this one that we have here. K over L is just multiplied, just to change them from H, because K for all of them, both of them are the same, L is the same. If I change this one to Nusselt number, I change this one to the Nusselt number, okay, therefore it can be easily simplified to this Nusselt number, because all of these parameters are the same, okay? Therefore the ratio of this one, the temperature difference is the same, K is the same, L is the same, and so on. Therefore it can be easily found to the ratio of this Nusselt number. Therefore heat transfer by horizontal to the heat transfer to the vertical, the ratio of these two is proportional to their Nusselt number, and that's become 1.53, okay?
Excuse me, sir.
Yes, sir.
Could you explain how you calculate Nusselt number vertical? Which equation you choose?
As I mentioned, in your textbook, there is only 2 set of correlation has been given. 2 set of equations been given, okay? For the vertical, I mentioned, again, we are talking about enclosure, right? Therefore, mention, do you have this set of equation, these 2, any Prandtl number. Therefore, you can apply it for water, you can apply it for air, you can apply it for anything, as long as satisfy this condition. One of the strict restriction is the aspect ratio, H over L. If it's H over L is this and satisfy this one, you can apply this equation. If it's H over L is between 2 and 10, and Rayleigh number this one, you can apply this one, okay? And the other set of correlation that you have for another range of Prandtl number. Mention if your Prandtl number is in this range and your aspect ratio in this range, you can use this equation. Now we end up either use this correlation or this correlation.
Okay, I see.
This one does not satisfy this part, this one does not satisfy this one. Therefore, here is 2 and 10, but our case is almost 30. Therefore, probably we can use this one with understanding there could be some error, okay? Therefore, in case in the exam you're trying to make the decision which correlation should we use, mention yes, this does not satisfy this condition, but however, this is the only choice I have, okay?
Okay, thanks.
No problem, sir.
Sir?
Yes, sir.
So we did not use for the horizontal one, we did not use the
Horizontal, the one we use it here, sir. Here, right now.
Okay, yeah. I forgot what was our RA number.
Okay. Therefore, this is the case that we have. Okay, let's move. Therefore, please again look at here. For the same delta T, the rate of heat transfer horizontal orientation is 50% larger than vertical. Why? Can you tell me why?
Because the convection helps the heat transfers.
Both of them are convection, sir. Both of them.
I know, but the fact that the bottom is hot and the top is cold, it helps the air circulate, which helps the convection, the heat transfer.
Absolutely, absolutely. Very good, sir.
Can you show the RA number again? I could not take it. I think it's a slide right before.
Oh, okay, please.
That's it, that's it.
Please write it down. If you need more time, let me know, okay?
That's it. Thank you.
Sure.
I didn't quite finish with the following slide, Professor. Would you mind going forward just for a second?
Sorry, I cannot hear it. A little louder.
Forward.
Forward, okay.
Thank you. Sorry, my mic is bad.
No problem. No, because again, please let me know because I don't know what how we can do that. Okay. Now, sometimes we have two pipe, one inside the other one, and this again happen in solar collector. Inside the fluid pass, this is the tube, and outside there's a glass. This one simple application, and you can have it in many other applications. If the solar radiation comes, hit this glass, this pipe is black, absorb radiation, and heat it up. The fluid is passing, but they put also another tube here, and this made of glass in order to reduce the convection. Therefore, we have two plates. We have two cylinder, one at this temperature, we call it TI, and we have another outside TO. Therefore, between these two, we have some convective heat transfer. Again, this is mainly applied to started to study because of the solar collector. Okay. Therefore, in this case, the characteristic length here, please pay attention. The characteristic length is the difference between these two. Okay. And since it's the diameter, they divided by 2. This is diameter divided by 2, give the characteristic length. Okay. And they use this equation because it is cylindrical coordinate. Again, therefore, this is the resistance we're talking. And they define effective conductivity. And the effective conductivity is simply calculated based on this equation. Okay. Again, look at here. These are trying to apply for different scenario. Again, this is equation they use to calculate the K effective, and there is some restriction. Again, it's not restriction because it's almost applied to almost a wide range of Prandtl number, except liquid mercury and so on, because that Prandtl number is not less than 1. And also based on this one here is, again, what is F? F is defined as this one. Okay, the geometric factor for 2-cylinder. Okay, if it's less than 1, with natural convection. Therefore, this is you have to calculate here. This is the equation they use to calculate the energy transfer by convection between two tubes, and the K effective is defined here. Calculated based on this equation. So you replace it here and that. Okay. Any question? Again, the same thing we have to look at here. The physical property of the fluid that in between, if it's air or one thing, is calculated average temperature of these two plates, TO minus T out. Okay, TO. Again, we have some equation for two spherical coordinate. You have one sphere inside another sphere. Okay. Again, the same procedure. The characteristic length defined diameter divided by 2. They use this equation to calculate and they call it effective rather than calculating Nusselt number and so on, because of this is a cylindrical coordinate is easier to use a definition, and they call it K effective. Okay, K effective, and then they use this correlation to calculate that value. Okay. Effect is equal, and this is missing here, equal to this one. Again, they've mentioned which range you have to use it, and what is the definition of this factor to define. Okay. And again, mention if the K effective ratio to this one is less than 1, therefore that means pure conduction. Therefore, if you calculate your K effective divided by here, the equal is missing. If it's less than 1, therefore that means this is only pure conduction. And that's happening between these two. Okay, there is no air movement, there is no convection path, that's all. Okay. Again, they give you one example for every application. At least you'll be exposed to the concept, to the idea, okay? Again, as we mentioned before, we can have both radiation and convection simultaneously. Again, we defined, again, look at here, in this case, one sphere is completely covered with the other one. Therefore, the shape factor from here to here is equal 1, okay? Shape factor here to here 1, okay? Therefore, in this case, you can calculate easily the radiation and add it to the convection process, and they become all of them. Therefore, you already know this is pure convection. We have procedure to calculate the pure convection and radiation. We have some idea at this moment, okay? And then we calculate this one, and you add them together and measure this, the total heat exchange between the two surfaces, okay? It's similar to the one that we had for forced convection. We calculate for forced convection, we calculate for radiation, then we add them all together, okay? Again, we remember we had the equation when we tried to do it. Let me go back again, just I want to understand the fundamentals rather than memorizing it. If you remember, we were doing some calculation somewhere earlier, and that was right here. When we wrote the energy balance equation, we end up this term. We mentioned now we have also another term related to the density change, and we call it buoyancy force. And then we went one step further, and we normalize. We end up Grashof number here, and Reynolds number to cover to bracket here. This is Grashof number. This is Reynolds number to cover to. Okay. Therefore, mention this to your energy transfer problem that you have here. There are two parameters affecting Reynolds number and also Grashof number. Therefore, this becomes Grashof number divided by Reynolds number. Okay. This is we discussed in the last lecture. Let me go here, and that we mentioned this is the relative importance of each one. Grashof number to Reynolds number 2. If it's less, this ratio is less than 1. Okay, what that means? If it's less than 1, it means the Reynolds number is so big that we can ignore Grashof, the natural convection. If it's equal 1 or more, it indicates that this one is dominating the system. That's what that's about. How about if it's between these two, what we have to do? And here I can show you the graphical procedure that we mentioned here, just to be able to grasp the idea. Okay, here they plotted that give you some better idea. Look at here is Grashof number, and here's Reynolds number 2. If it's in this range from here to here, you can see, look at here, in this range that you have right here. Indicate what? And you look at here, indicate what? It mentioned here is free convection is dominating. Look at here, in blue one, here is mentioned the forced convection. Okay. In this range, from this range to this range, both of them are working. Here is your pure convection, and here is your forced convection. Okay. Therefore, now we can approximate that both of them are contributing. Therefore, now you have this criteria. Any problem that you solve, if this ratio, Grashof number, and here is less than this part, you can ignore natural convection. If its ratio is more than 10 from here, right here, that it indicates the forced convection is negligible. Okay. Anything between these two, between this one and this one, we can see both of them are contributing. Okay. Therefore, this
So
yes, sir.
We have to include both?
Yes.
Okay.
Yeah, I'll give you some example.
Okay.
Look at here. You have a plate is hot. Therefore, you have a natural convection. Okay. And sometimes they put a fan here. Therefore, these two, both of them are contributing to to the same direction, okay? Therefore, in this case, I have to consider forced convection created by a fan and natural convection by here. If I do not have this fan, I can consider only pure convection. If I do not have any temperature difference, I can consider forced convection, okay? Therefore, it's trying to tell you in some problem, we can have both phenomena simultaneously. Now, both of them, they can help each other. In this case, both of them helping the plate to be cool, okay? Because the direction of this one, the direction of the fan, and both of them are helping the convection, okay? Because both of them are going up. Sometimes bad design, the plate is cold, is coming down, convection is pushing down, but the fan pushing up. Therefore, they're, rather than helping each other, they're working against each other. Therefore, we have to be able, both of them are combined, but we have to be able to distinguish between these two, how we can solve here, because both of them here are adding to each other. Here, the force fighting against this one, okay? And something like this, the fan is going in this direction, the convection going in this direction, okay? Therefore, it's the transverse. Again, in your textbook, they gave you one example how to solve this problem, okay? And that's for vertical plate, for this scenario. We don't have for this transverse. We have for the case they are working together as a team or fighting against each other, okay? In assisting flow, in this one, the buoyancy motion is in the same direction as a forced convection. Forced convection. Therefore, the natural convection help this one. Therefore, they will add it to each other, work together. In the case of opposite here, the buoyancy force is against the forced convection. The buoyancy force coming down because cooling down become heavier, it come down, but fan is pushing it up. Okay, that's the case. In the third case, they are perpendicular to each other. Okay. Now we don't have any example in the class in text for you, but for this case, we have a simplified equation that we can calculate the combined effect of force and free convection, natural convection. Okay. Therefore, again, let me go back. First, we have to make sure that satisfy this requirement, and if it's both of them are together, working together, we have to go back to see if it's this scenario or this scenario. In this case, as I mentioned, we have one set of equation. I've mentioned here is the combined Nusselt number, not the heat transfer, not the H. The combined Nusselt number is a combination of force to power n plus natural convection to power n, and take the roots of n, okay? Therefore, this to n to power n and the roots of n. When they are working together as a team, they add it to each other. If they're opposite in each other, become negative, okay? Or determine correlation from pure convection. So therefore, I have to go to chapter 7, calculate the force convection, because this exterior problem. I have to go to chapter 9, beginning, to calculate natural convection to see which scenario it is. And then I plus sign if they are the same direction. And if it's an opposite direction, you have to be minus. This is minus in the opposite direction. It makes it. Okay. And between 3 and 4, depending on the geometry. But for the vertical plate, n is equal to 3. Therefore, now, when we solve any problem in real life scenario, we have to see which force is dominating. Natural convection, forced convection, and then if we see if one of them, both of them are the same magnitude, therefore we have to come and add them together. If natural convection is dominating, therefore we can ignore this one. If it's forced convection is dominating, we have to ignore this one. But if they're the same order of the magnitude, we have to consider both of them. Again, this equation, as I mentioned, is for vertical wall that we have, and n can be applied for that one. Again, we have, yes.
When you say ignores, it means we don't include it and we calculate it as is.
Yeah, but the same problem that we had before.
Okay.
Forced convection, but if it mentioned, if the problem we did it before, if the problem mentioned, well, there is also wind moving with the velocity of 2 meters per second, therefore we have the temperature difference between plate, and we have also wind, therefore we combine to consider both of them to see which one is dominating. Let's look
Okay.
at a good question. Excellent question. Let's look at this one here.
Wait, sorry, I have another one.
Yes.
Why does it say plus and minus? Is it for that reason?
Because right here. Here,
Or for different of direction? Okay, okay, yeah,
for the
perfect.
same
All right.
direction, they're
Yeah.
both fighting against each other.
Yeah, direction change, okay.
A 12 centimeter high and 20 centimeter wide circuit board. Again, this is dealing with the computer, okay? Houses 100 closely spaced chips. On its surface, each dissipate 0.5 watt. Therefore, we have a plate, right? And there is a heat coming out of the plate, and he mentioned here is very closely spaced. It means we can assume this is almost one plate, okay? It's not a fin, it's only one plate, okay? The board is cooled by a fan that blows air over the hot surface of the board at 35 degrees and the velocity of this one. Therefore, we have a board here, there's a board here, and we have a fan down here working here, okay? The heat transfer from the back of the plate is negligible. Therefore, if the back of this board is insulated, we can assume there's no losses. Okay, whatever energy generated has to be dissipated from front surface. Determine the average temperature of the surface of the circuit, that plate, assuming the airflow is vertical, upward along 12 centimeter long. Therefore, we assume this, we have a plate, 12 centimeter, and we have a fan bottom here and going the same direction. Could you please read? In order to help you, because it mentioned here, determine the average temperature of the surface. Therefore, if you like trying to calculate the physical property of the fluid, you do not know what is the temperature, but he gave you evaluate the property of the film at this one. Therefore, you go back and look at the temperature, the physical property of the air at 47.5. Trying to do it, okay? The first thing you have to do here, you have to go table 8.15 and look at the physical property at 47.5. That. And then we mentioned there's a vertical plate, therefore, and you're assuming that there is some heat generation. How we are going to solve this problem?
We need the Grashof number.
I have no idea really. Put your idea together before put any equation, okay? Because I was just thinking if I want to use Grashof number, I need the temperature difference.
Mm-hmm.
Because if I look at here, I have here air coming at this velocity, at this temperature. And here we are generating heat around, let's say, 5 watt. I'm trying to find what is the temperature of this plate. It mentioned determine the average temperature of the surface. Why mention average surface temperature? What that means? I know one of the students asked me at the beginning of the class. Again, here is not a constant temperature, here is a constant heat flux. That means the temperature from here to here is changing. Okay, there is a vertical plate, constant heat flux, constant heat flux. Therefore, we usually take the temperature at the middle, or we call it average temperature. That's why I mentioned average temperature. Average temperature of the surface, because the temperature here is different from here. Here, the cold air comes here, it cools it down. Here, the temperature is higher, okay? Therefore, we mentioned if it's vertical plate, and if it's constant heat flux, the temperature, we take the middle temperature, or we call it average temperature, okay? Read the problem, pay attention to every word that's there, okay? Therefore, as usually we go here, we do this one, it's assumption, we mentioned to take the mean temperature, and then he asked us to take the temperature from here. That means if I go back and work it reverse, the temperature of the surface, I can assume 60 degrees. So I can assume 70 degrees. Therefore, I do not need this one. I can assume 70 degrees and calculate the average temperature. But he mentioned we can solve it here. It gave us the right direction. I can assume 80 degrees, okay? But here, since he mentioned, I can work backward and say, this is my temperature of my surface. Now I have assumed a temperature for the surface. I have all the information. I can go and calculate my Rayleigh number. Okay. Therefore, I can go back, table, find all this physical property. I know the conductivity. I know this. I know this. I know beta. Therefore, I can calculate G. Grashof number is G beta temperature difference characteristic length to power 3. Characteristic length here is the length is 12 centimeter and kinematic viscosity. Okay. Therefore, if I do that one, okay, first you calculate Reynolds number, no problem. Therefore, he assumes at the beginning is force. Okay, I'm sorry. He assumes force. He calculates Reynolds number. We know the velocity. We know the physical property, and we calculate Reynolds number. And it is 3,383. What that means? Is it force or is it laminar?
Laminar.
Is it? Yes, it is.
Laminar.
It is laminar because it's a plate and external over the plate is less than 500,000. It's laminar. Therefore, I can go and calculate my Nusselt number using this equation. This equation for laminar. And then we can calculate here. I can find heat transfer coefficient here. But at this moment, I should stop here and say this is my Reynolds number and go back and calculate the Grashof number, okay? Therefore, now we calculate this is if I assume it is only forced convection and I have this value of heat transfer rate, okay? Then I can go back. Any question, please? Okay, finish it, then let me know that I can move to the next slide, please.
Sir?
Yes, sir.
So why did you tell me that we didn't have the, when I told you that I want to get the Grashof number?
Yes, still I'm telling you why.
You said it's not possible because we don't have the temperature, but
yes.
I assumed the same thing.
Oh, you did not assume. No, we were here. No, we were here, okay? You mentioned that you're going to do that. Tell them, fine, okay. We were here, right here. You mentioned you're going to calculate the Grashof
Yeah.
number, fine.
Because it was given the TF.
TF, but you didn't tell me that you can calculate TS. Remember, the Grashof number that you have is T surface, not
TS.
TS,
Yeah.
not TF. Okay, no, well, I'm wrong. Okay, so no problem.
I know it's not TF.
Good. I'm sorry, I misunderstood that. Therefore, now we
Okay.
calculate the force convection, and then we go to move. We calculate if we can, because we have the force convection here. This is Reynolds number. This is my Nusselt number. This only go to the force convection. I can calculate the area because I mentioned 17 times some 10 centimeter, and then calculate the heat loss. Therefore, here the area, and here the equation that we can calculate. And from here, we find the third surface is around 61 degrees. Then what else we should do?
This to the natural convection.
I do not know. I'm trying to find what should we do next. What should we do next? I read the problem and tell me what should we do next. The first part, we ignore natural convection. Now, is it a good assumption or not? No,
Yes.
I do not know. Again, we mentioned, let's consider the contribution of natural convection, because we cannot say, yes, it's good, because I do not know the magnitude. I have no idea if it's good or bad. Because the first one, we ignored natural convection. That's why we could focus on force convection. So now, is it a good idea or not? We have to go back and verify. Verification here is, now we look at the Grashof number. And we look at the Grashof number, and then we calculate the ratio of Grashof number to Reynolds number to see what is in the range. Is it less than 0.1 or is more than 10 and so on? Therefore, by ignoring it, yes, we got some number and we solve the problem as force convection, heat loss from the plate, and we found, yeah, the number is okay. And we say, well, that was a good assumption that we started 47.5. Now let's go back and solve the problem and say, no, we do not know is only force convection. Let's consider also the natural convection phenomenon to see what is the contribution. In that case, we go and calculate Rayleigh number. Again, base, as you mentioned, my friend, temperature of 60 degrees. Now we look at to see what is the contribution of natural convection. And this is my Rayleigh number, okay? This is my Rayleigh number. Then I can go back and calculate the ratio of Rayleigh number over to the force convection, or I can go just for curiosity to calculate the Nusselt number. And we find the Nusselt number here like this, okay? This is one of the correlation that you have for vertical plate. You can use this one, or you can use the other equation. If you remember, this is for all the range. This is for the all range. If you don't remember, let me remind you that what I'm talking about. Remember, in this one, we have, instead of a correlation, we have this correlation, we have this correlation, and we have this. This is only applicable in this range. This is applicable in this range, but this is for the whole range. Therefore, you can use this correlation or any of them that apply to that range, okay? Therefore, this is one of the correlation that we have, okay? Let me go back. And this is the correlation that you have here, right? Look at here. This is the one we used it, or you can use the other one that in that range. And then we're trying to look at here. You can see your Nusselt number is 22. Let me go back. And here your Nusselt numbers was 34, okay? Or you can go back and calculate the ratio of the Reynolds number and Grashof number. Do that to see what is the assumption, okay? And since it's a vertical plate and both of them are the same direction, we add them up and mention for vertical plate, n is equal to third, We put it on here and find this at the combined heat transfer. Okay. And now we can see here. Now the question here is if it's imported or not. The only one indicator that we can look at here is the ratio of Reynolds number to Grashof number to Reynolds number to square. Calculate and tell me what is number. Could you please calculate, because I don't have the calculator here.
Should we use the Reynolds number square?
Yes, it's
Right.
Grashof,
Yeah. Okay.
Rayleigh number,
Yeah.
the Grashof number, Reynolds number to power 2. Is it? Are you going to buy the battery or calculator? Any number? Grashof,
0.26.
how much?
0.2657.
Therefore, it means it's more than 0.1. Therefore, that indicates that both, you have to consider both natural convection and forced convection. Therefore, if it's between 0.1 and 10, indicate that you have to consider both of them. There is a mistake in your calculation because we have to calculate the Grashof number to power 2 over Reynolds number, not Rayleigh number, okay? In the expression is Grashof number, it means this number divided by this number. Therefore, that number will increase. Therefore, you have to calculate. Grashof number divided by Rayleigh number to power 2, okay? Just assume this one. In that case, you have this number divided by this number, because this number is Rayleigh number. Therefore, if we divide this number by this number, become almost 4 to 10 power 6, okay? And then you have also your Reynolds number. Your Reynolds number is this number, okay? Therefore, that's become between something around 0.3. It means it's more than 0.1. Therefore, indicate that you have to consider both phenomena, natural convection and forced convection. Any question? Any question, ladies and gentlemen? Therefore, theoretically, we are chapter 9 finished, but we are going to do 1 or 2 more problems. To show you the procedure, please read, study, please do the problem, because your is not understanding of the subject, but trying to do the problem, okay? Because the way I marked, I noticed some of you have, I believe you have not used your calculator for a century. Anyway, any question, please? Any question, please? Anyway, done. Have a nice evening. I will be there another 5 more minutes because today I have to work hard because I have another lecture at 9 o'clock tonight. I'm giving a lecture to the student in China. And there is 12 hours time difference. It means over there is 9 o'clock in the morning. Here is 9 o'clock evening. It means, yes, say it again, please.
No, I was saying that's cool. That's very nice. Sir.
What is good, sir? You're sleeping. I'll have to work. What is good about it, sir?
No.
Start 9 o'clock, finish at 12 o'clock midnight, sir. And that's dealing with the question of issue of air quality, aerosols, COVID, and so on. Anyway, that's my problem. Anyway, have a nice evening, ladies and gentlemen. Please study, please study. I will send you the solution. Then I mentioned how I mark. And again, I was sort of a little bit relaxed because I know you were under stress. But what I saw in your exam paper was not because you were nervous, because in some cases, okay, there was some basic misunderstanding of the subject.
Sir, will we be getting our second project grade soon?
He hasn't sent it to you. I will send him an
No.
I will
Thank
send
you.
I will send him an email immediately, and I will ask him to do it as soon as possible. Definitely. I'm sorry.
Thank you.
No problem.
Have a great day, sir.
You too, dear.
Thank you, sir. Have a good evening.
You too.
Thank you. Bye.
Thank you. Bye. Have a nice evening, all. Stay safe, please. Please stay safe, because there are some people that are stupid. They are playing something stupid game. Take care of yourself. Take care of your family.